Wade Rose is next, and he's going to be giving us a presentation with the title that you see up here.
So the title is a bit of a mouthful. So basically I'm going to be talking about urban trees and the services that they provide residents and ways that we can decrease tree mortality through better management practices. So quickly the outline, talk about urban forestry, how trees reduce air pollution and water pollution, their uses in remediation, reductions in urban heat islands, their ability to improve mental health, and ways we can increase tree survivability. So what is an urban forest? Well, there's two components to it. So first you need an urban area. You can see the green tiny dots on that map represent populations of 2,500 to 50,000 people, and the purple areas represent populations and land areas of 50,000 plus individuals. And this currently composes about 4.5% of the total land area in the United States. And the second component, of course, is trees. And these trees come in means of yards, parks, streets, and remnants of old forests. So it's a combination of both public and privately owned woodlands. And then from this, we come up with urban forestry, which is the care, maintenance, and study of trees within an urban environment to achieve the maximum environmental services for the surrounding communities. So states of our urban forests. So nationally, we have about 3.8 billion urban trees, and this seems like a lot, but when you take that into consideration that a healthy urban forest is about 40% canopy cover, nationally we fall well short of that at 27%. Statewide, 78 million trees, and again, we're very below the average at 18.9%. In the city of Detroit, we're currently conducting a survey, and using GIS software, we've been able to determine that the tree canopy is around 22.5%. Unfortunately, we're losing about 1% of canopy cover every single year, and 1% might not seem like a big deal, but this evens out to be about 4 million trees. And these aren't small trees, so we're talking about very large, mature trees. So the canopy reduction will be increased as we lose more of these trees. And as urban expansion continues, as right now we're at 4.5%, and that's expected to shoot up to 14% by 2050. So that loss of trees is going to increase exponentially. So what happens when we lose these trees? Well, we lose environmental services. So as you see this image up here, this is a picture of the city of Detroit under one of its many smog advisories during the summer. Criteria air pollutants are a major problem in urban environments, and they're both primary and secondary pollutants. Primary are those that affect human health, and secondary are those that affect the environment. These include ozone, sulfur dioxide, nitrogen dioxide, lead, and particulate matter. So what are the impacts on human health? Well, increased rates of emphysema, asthma, heart and lung disease, heart attacks, and premature death. So these are some pretty nasty stuff that we put in our environment on a regular basis. And currently there's about 150 million people that live in non-attainment zones for these criteria air pollutants. So I would encourage you all to go to the EPA's website, type in your zip code, and find out exactly what it is that you're breathing in. So surprise, trees reduce ambient air pollution. And they do this through photosynthesis. They absorb ozone, NO2, and SO2. These are converted to acids and stored in leaf biomass. So during recent studies, ozone was found to be reduced by 20%, NO2 by 35%, and SO2 by 70%. And through a little bit of extra research, I found that trees actually prefer, in equal concentrations, they'll prefer SO2 over all the other ones. So they have like a favorite food as far as air pollutants go. Particulate matter reduction, this comes in two different ways. Through direct interception, so by the particulate matter contacting leaf surfaces or bark surfaces, as well as inertial impaction. And this is when air currents move over leaves and bark, and the particulate matter gets trapped in an eddy effect over that surface. Unfortunately, about 50% of these, and these are the ones that play the largest role in the detrimental impacts on human health, is that 50% of the particulate matter will become resuspended, so they're not actually removed completely out of the atmosphere, and they'll become resuspended under normal atmospheric conditions. Nationally, this is a big environmental service. It equates to about $3.8 billion annually. Statewide, it's $87.5 million, and the city of Detroit receives a benefit of $5 million from the urban forest that we have here. So CO2 emissions, this is another really big one. So globally, CO2 production is around 34.5 billion metric tons annually. We're pumping this stuff into the atmosphere at unprecedented rates. This is one of the main components driving climate change. And surprise, guess what? Trees sequester carbon. So rates of sequestration depend on three factors. So it's the density or the number of trees per hectare, the diameter distribution or the diameter at breast height of those trees within the hectare, and then the age of the tree stand. So nationally, trees sequester about 22.8 million tons, and this is a $460 million value. But the big one is how much they store. They store 704 million tons, and this is about $14.3 billion. That just having trees in our country, this is a service that they're providing us. Statewide, it's a $15.2 million value. In Detroit, unfortunately, we're losing trees, so we only sequester about 4.2 tons. And I was unable to find numbers as far as how much the trees are storing. Stormwater runoff, we lose this all the time, and trees are a major factor in this. So impervious surfaces increased runoff by 88%. If you attended the previous presentations, you'll see that from John and Jenny as well, that this is a major issue within urban environments. And it's a leading source of water quality impairment. And surprise, guess what? Trees can help out here too. They reduce stormwater runoff in 3 ways. One, through interception. So in a forested area, it doesn't even need to be a natural occurring forest. It can be a park. Rates of impaction on soil will be decreased by 10 to 40% from the tree canopy. And a large mature tree can hold up to 100 gallons of water in its canopy. Another way, through infiltration. So on mildly compacted soils, and this is another major problem in urban environments, with compacted soils, trees were able to increase the infiltration rate by 63%, and on severely compacted soils, they were able to increase this rate by 153%. And of course, species selection is very important. You want to choose species with very porous root systems, such as oaks, as opposed to those with fibrous root systems, such as maples. The last way is through absorption. Trees are thirsty organisms, and they can uptake about 100 gallons of water per day, and on average, about 4,000 gallons of water per year. The city of Detroit receives an amazing benefit. We have a major problem with CSOs in this area, and about 191 million gallons of water is removed annually from the CSOs. That's a $382 million value that these trees provide. Their uses in remediation, so concentrated industrialization, which Detroit is known for, puts hydrocarbons, metals, and solvents into the soil, and this prepares new economic growth, such as new construction and urban agriculture, which is a new field that's emerging in the city of Detroit. They actually have the largest concentration of urban farms of anywhere in the entire country. So by eliminating these, we can definitely move industry along. So current methods are incredibly expensive, such as dig and dump and encapsulation. These 2 methods don't even take into consideration the actual toxicity of the soil. Basically, you're just removing it and putting it someplace else, or you're just putting a Band-Aid on it. And finally, the last one is soil washing. And this one actually removes the toxins, but unfortunately it also removes all the biodiversity in the soil as well. So trees can be used in phytoremediation. There's phytoextraction, phytodegradation, rhizofiltration, photostabilization, and phytovolatilization. And the main ones are the phytoextraction, so that you can actually harvest the tree, and then the rhizofiltration, where the material is stored in the root system of the tree. But there are factors that affect phytoremediation, such as the extent of the contamination in the soil. If the soil is too toxic, nothing will grow there. The bioavailability to the rhizospheric organisms surrounding the root system, and then the tree's ability to intercept, absorb, and accumulate those metals and toxins in their biomass. So contaminant behavior. Once these metals and toxins enter the tree, they all behave differently. And common ones that are used in industrial processes include lead, chromium, and copper. These tend to be stored in the root systems of trees, whereas cadmium, nickel, and zinc are stored in the woody tissue and the leaves of the trees. And again, these all present different issues and problems that you have to deal with. The roots will need to be excavated if the property is going to be completely renovated with new construction. With woody tissue, down branches will need to be removed. As they decay, they will just put those pollutants back into the soil. And lastly, leaves. This is a big one because through leaf drop and wind action, the contaminants can actually become mobilized, and you can actually spread the contamination. And they can also bioaccumulate in higher trophic levels through herbivory. So this is definitely things you need to consider before you implement any type of phytoremediation program. So trees and urban heat islands. So urban heat islands are created when vegetative surfaces are removed, and that's something that we're definitely looking at as we progress towards that 14% of all land cover being urbanized. So this increases air temperature. Daytime temperatures can reach almost 30 degrees, nighttime temperatures 20 degrees warmer, and ambient air temperatures can be about 5.5 degrees warmer than the surrounding rural areas. And guess what? Trees reduce urban heat islands. Surprise, surprise. And they do this in two ways. One, they impede solar radiation and conversion to latent heat. This is a fancy, fancy way of saying they provide shade. Okay? So in a Davis, California study, they compared incidences of solar radiation to shaded and unshaded areas, and the results were pretty interesting. So in the unshaded area, it was 940 watts per meter squared, and in the shaded area, it was 185 watts per meter squared. So it's a large reduction in the solar radiation, but then you compare the two temperatures. In the unshaded region, it was 140 degrees Fahrenheit, and in the shaded region, it was 104. So it's a 36-degree decrease just by having shade trees there. And the second way is through evapotranspiration. So again, trees will transpire about 118 gallons of water per day, and this actually removes heat from the soil in the form of megajoules. So again, you're reducing the ground temperature as well, and therefore reducing the latent heat that's moving into the atmosphere. And a 10% canopy cover, now this is going back to the 40% canopy cover that I had mentioned earlier. So with every 10%, you're going to lose about 2 degrees Fahrenheit off the overall ambient air temperature. And this reduces CO2 and energy use because of the 68-degree threshold. So every degree above 68 degrees, it corresponds to a 3% increase in overall city energy use. All right? So healthy canopy cover can reduce a city's energy use by 12%. And this means reduced CO2 emissions. So do you guys remember all those large numbers that I was showing you earlier about the amount of carbon sequestered and all that? Well, just from the emissions being reduced, it will actually be greater than all the carbon sequestered by trees in the United States. So just by having these shade trees can have a larger secondary impact than having the trees there just by themselves. So this would equate to air pollution and energy savings of around $10 billion. So this is a pretty big thing. So by having more of this, we reduce the need for this, and we get less of this. So moving on from environmental stuff to us, all right? So there are several aspects of overall health. We've talked a lot about the physical stuff, so their impacts on rates of emphysema and asthma, heart attacks, things like that. But also we have to take into consideration mental health and overall social well-being. So currently there are 450 million people in the world that suffer from some type of mental illness. And 25% of all the population will develop some type of mental disorder over their lifetime. And the main component of this is depression. So what is causing this? Well, it's urban living. We live in unnatural built environments. That's also our contemporary work practices and the type of work that we do. We don't work outside anymore. We sit in offices and cubicles and we stare at computer screens. And environmental degradation. When we live in crappy areas, we feel crappy overall. One study concluded that the loss of green space had the same type of mental impact as losing your job and or you're having your house foreclosed on. So that's a pretty considerable mental impact. So how do trees and green space help this? So in one study conducted in Pennsylvania of hospital patients, there was two different sets. One group was given a window with a view of an urban setting, which is their top photo, and the second group was given a view of an urban setting with trees. Just strictly a visual stimulus. And they found that they had reduced levels of stress, blood pressure, anger and aggression towards their caretakers decreased, the amount of pain medication that they needed post-surgery decreased, and their recovery times decreased. So what happens with direct contact with nature? And this comes in the form of walking in the woods or sitting in the woods. It's also known as forest bathing. Well, again, you end up with reduced stress, blood pressure, anger and aggression, and blood glucose levels. This was found to be a more effective treatment for those with diabetes than exercise and minding their diet. So just by sitting in the woods was more effective than all that. Also, the immunoglobulin levels in your bloodstream increased. And this is the main component of your immune system. So overall, just by sitting in the woods, you're making yourself healthier. So why is this so effective? Well, the attention restoration theory, tries to explain this, is saying that generally we say like, oh, I watch movies, or I watch TV, or I go to sporting events, or I go to the gym. Well, these types of activities are a form of hard fascination, and they become the main focus of your attention. And it actually takes a secondary stimulus to break that focus. So when this happens, there's no inner reflection. You don't deal with your problems, you don't deal with the emotions that you might be feeling throughout the course of the day. Trees in green space offer a form of soft fascination. And this gives you a sense of being away and escape without actually having to go anywhere. They also engage you, but they don't become the main focus of your attention. So again, you're able to do some inner reflecting and process emotions and things like that. And they also develop a level of comfort. This decreases mental fatigue, which decreases aggression and violence. And one study in Chicago found that there was a reduction in violence of 56% in the areas that had trees over trees that did not. So real quick, there's 7 factors that affect tree life expectancy, and that's site selection, improper planting, insufficient water, nutrient deficiency, soil compaction, mechanical injury, and vandalism. And this decreases the tree life expectancy to 7 years. So what can we do? We can implement proper planting methods, standardized procedures, and maintenance training. And as far as vandalism goes, we can start to engage communities and encourage them to plant trees. It develops a sense of ownership within the community. And this increases tree survivability to 95% and the overall life expectancy to 24 years. So the conclusion, environmental services, trees provide a lot of them, and they're valued at billions of dollars. Yay! If that doesn't do it for you. They improve our mental health and overall physical well-being, reduce stress levels, violence in our communities, and overall improve our communities. But overall, the bottom line is that we have to decide how we want to live. So I hope through this presentation, you guys have all gotten as excited about trees as I am, and that you'll want to go out and plant more trees. So with that, thank you very much. Yes.
What were some of your sources for all the mental and physical effects?
There is a treatment known as Shinrin-yoku in Japan, and that's been widely accepted since the 70s as a medical treatment. And then Kaplan from Ann Arbor was the main sources for here. And then Dr. Ulrich conducted that first study in Pennsylvania. So
Okay.
if you Google any of those names, they should all pop up as
All right.
sources. Kyle.
When you say the top 5 types of trees for urban planting are the top 5 best all around?
Top 5 best all around. You can never go wrong with oak trees, maple trees, any type of linden. Boy, off the top of my head, you're really putting me on the spot. But those 3 actually encourage more biodiversity. So those 3 are like the main hard hitters right there. And Kentucky coffee tree. Anything that's in a floodplain, you want to uptake a lot of that water. So those 4 are pretty much go-tos. Yes?
You know how many trees you have to have in relation to your size to be considered a tree city?
A tree city? I know American Forest shoots for 40%. It's hard to get like a solid number on that because of canopy size and density. So they generally just give it like a percentage. So 40% canopy cover definitely gets you up there as far as a tree city. Yes?
For your urban utilization, it actually increases by approximately 3
Yeah. So it'll be the ground temperatures will actually increase by as much as 30 degrees as opposed to rural areas. So.
Remediation, toxins, I'm assuming, are also stored in the trunk of the tree?
Yeah, that would just be the woody tissue.
Yeah,
Yep,
so
right.
what do you do with those trees when you cut them down?
Okay, so they're cut down, you chip them up, and then you incinerate them. And through the incineration process, you're able to extract things like lead and all the other hard metals that are in there. Unfortunately, this also emits CO2. So you have to, in turn, plant more trees to counteract the amount of CO2. But you're basically taking a lot of scattered hazardous waste sites and brownfield sites, and you're just making one, basically. Or they could be put into a hazardous waste landfill. Donna?
As far as the trees good for biodiversity, is there any evidence that any species of trees are better at sequestering CO2?
I know that any type of conifer is better than a deciduous tree because conifers sequester CO2 year-round, whereas deciduous trees are only during the in-leaf season. And I think I'm getting the hook. But one more question.
So it seems like when you use the trees for remediation purposes, that the pollutants of kind of systemic type of nature that they get into the leaves and roots and the woody tissue. Is there any indication that the offspring of those trees are affected by this pollutant?
Generally, the trees that are used are all hybrids, so they're either, they tend to use tree species where it's one sex or the other. So it would be monoecious trees, so they would never produce any offspring. So it's kind of like a one-time function and then they're out. So that's kind of a downside to it.